Welcome to 3.4's Math Moment. Today students learned about how to divide with decimals. So we're going to look at a couple of examples. The first one says divide, but be careful to consider which number is the divisor. Lots of times when students see it written this way, they just want to throw it in however they like. But it's important to know that the first number always goes in the house, inside the division box, and the second number is the divisor or belongs outside. Alright, so this is how we would set up our problem to solve. When students learn to divide with decimal numbers on the outside, they have to move the decimal to the end of the number. So if the decimal has to move one spot on the outside, it also has to move one spot on the inside to keep the problem equivalent. The number 27 doesn't show a decimal right now, but we know and we teach students that all whole numbers always have an invisible decimal at the end. So I know that this number has a decimal at the very end of the 7. So if I need to move it one spot, I will do so, and we always fill in any extra spots with a 0. So if all of these loops look confusing to your student and it starts to get them off track from the actual problem, I always suggest rewriting the problem after you make your loops and move your decimal so it's easier to look at. So this is just simply the problem 270 divided by 9. Now I'm going to decide how many times 9 can go into 2. 9 is too big, so it cannot go in. So now I'm looking for 9 times something to give me 27. I know when I count by 9s, 9, 18, 27, that 9 times 3 gives me 27. And then I bring down my 0. How many times can 9 go into 0? Well, 0 times. And I know that I'm not going to have anything left over. So my answer for this problem is 30. Now, the next example is a word problem. It says, Evie's mom sent her to the store with $20 and told her to buy as many apples as she can. Apples are on sale for 87 cents each. How many apples will Evie buy? Now, if I've got $20 and the apples are on sale for 87 cents, it might be confusing to students about which one they should split up. Alright, but I'm going to the store with $20. That's what I'm going to spend. That's what the cashier is going to split up when I try to purchase apples for 87 each. So we always do the number that we are splitting up goes on the inside of the division house. Well, and what am I splitting it up by? I'm splitting it up by 87 cents each, which 87 cents has a decimal in the front. So we use the same strategy of moving the decimal from the divisor to the very end. This time I'm going to have to move it twice to get it to the very end. Again, 20 does not have a decimal right now, but we always know that there's an invisible decimal after the ones place, and I just have to move it twice and add 2 zeros. Again, if this is hard for your student to look at, encourage them to just quickly rewrite the problem without decimals, or if it's a problem where the decimal will stay in the problem wherever the decimal falls. So I need to decide how many times can 87 go into 2? Well, I know it won't go in at all because it's too big. How many times can 87 go into 20? Again, too big. How many times can 87 go into 200? Well, this is where I'm going to have to use my strategies that we learned in 3.1 and 3.2 because I don't know my 87 multiples by heart. So I'm going to have to pick something to try. I know that 87 is pretty close to 100, so I don't want to go too high, so I'm just going to try 3. 3 times 7 is 21. 3 times 8 is 24, plus 2 would give me 26. So I got 261, which is too much. So now I'm going to try 87 times 2. 2 times 7 is 14, carry my 1. 2 times 8 is 16, plus 1 is 17. And even though that seems like it might not be close enough with 174, it's pretty close, and I know it's as close as I can get because times 3 was too big. So I'm going to place my 2 on top, 174 goes down below, and then I subtract. I can't take 4 away from 0, and I can't borrow from a 0, so I have to go all the way over to the 2. This becomes a 10, but I have to borrow from it, so it becomes a 9. This one gets to become a 10. 10 minus 4 gives me 6. 9 minus 7 gives me 2. 1 minus 1 is 0. I bring down my 0. Now, it's nice that I kept this work over here, because the problem now that I'm looking at is how many times can 87 go into 260? Well, 87 times 3 is just 1 too much. So I'm going to have to use 87 times 2 again. And I know that what that is already, because I already did it. It's 174. And so I just subtract. I'm going to have to borrow from my 6. 10 minus 4 is 6. 5 minus 7 I cannot do, so I have to borrow again. 15 minus 7 I can do, and it's 8. So my remainder becomes 86. Now, it says, how many apples will Evie buy? So she's going to buy 22 apples. I have a remainder of 86. Okay? Because my remainder is 86 and I want to know how many apples I have to buy, that remainder is actually cents. It's 86 cents that I have left over, that Evie has left over to take back to her mom. But the question wants to know how many apples, and how many apples she can buy is 22. If you have any questions about this lesson, make sure to see your math teacher.